Hey everyone. So in this video, I'd like to say a few more things about the domain of a function. And so in the last video, we said that the domain of a function is a set of all input values for a function, and that the range of a function is a set of all output values for a function. And like I said earlier, I really like to focus on the domain in this video, in particular the domain of equations. So we ended our last video by talking about the domain and range of a few specific examples, a few functions from our list of common functions. And so f of x is equal to x squared, g of x is equal to the square root of x, and h of x is equal to 1 over x. So maybe I'll just quickly draw a rough sketch of the graphs of these functions, right? So here we get something like this. For x squared, we know that for the square root of x, we've got the points 0, 0, 1, 1, and 4, 2. We get something like this, sort of half of a horizontal parabola. Let me adjust this a little bit. And then for 1 over x, we get this sort of split graph. So more or less like this. And again, I just want to focus on domains in this video. And we said that the domain of this first function, well, no matter what value I plug in to this function, I can always square it and get an output out. So really any number I can plug into this function and get a reasonable output out. The domain is negative infinity to positive infinity. For this g of x function, the square root function, we said that the domain was from 0 to positive infinity. The idea here is that we can't plug in any negative values into this function and get a real number out. Right? What does the square root function mean? It says, what number squares to the inside, right? If I plug in the square root of, if I plug in x, right, or x is equal to 16, right? Computing the square root of 16 gives us 4. Right? What number squares to this inside? But if I plug in something like negative 16, it's asking us what number squares to negative 16, and if I pick 4, I get positive 16. If I pick negative 4, I still get positive 16. I really can't think of a real number that does the job here. And so here we're just going to leave it as undefined for the moment. We can't plot a corresponding point on this coordinate plane in terms of x and y. And so here the domain is really all non-negative numbers, so from 0 to infinity. For h of x, we said that, okay, well, this is describing division, right? 1 over x is describing division, dividing 1 by whatever number we plug in. And division can go wrong in one way, as when we divide by 0. So we can't divide by 0. That leads to an undefined quantity, an undefined result. And so I can't plug in 0 for x because that leads to division by 0. So the domain is everything but 0. And so most of our common functions, and most of the functions we'll encounter in this class, sort of fit this bill here where the domain is all real numbers. I mean, I don't want to say this blanket statement that it's going to be true all the time, but the other functions on our list of common functions all have a domain of all real numbers. And really, when things might go wrong, or two ways that the domain will typically be restricted for functions in this class are kind of in these two ways. Either we're restricting the domain of a function because it leads to taking the square root of a negative number, or we're restricting the domain of a function because it leads to division. So these are two common ways a function will be restricted. a function's domain. And so I want to talk about this in the context of equations now. Here I've got a list of 4 different kinds of equations, and I want to find the domain of these 4 different equations. And so if you're feeling up for it, please pause the video and try out these examples yourself. Write your results in interval notation, and then we'll cover these problems together. So let's start with this first function, f. So f of x is this rational function, 2x over x squared minus 5x plus 6. And so, what can go wrong when we input into this function, right? It's talking about division here. And division can go wrong, right? Dividing by 0 is undefined, and so any input that leads to division by 0 is not something I can really input into this function and get a reasonable output out of it. Such an input will not be included in the domain. And so we want to look for when our denominator produces 0, right? Because that'll lead to division by 0. We want to toss out inputs that lead to division by 0. In other words, really the solutions to this equation, x squared minus 5x plus 6, these are the solutions, these are the inputs that give us division by 0 and should be tossed out of our domain. All right, so here x squared minus 5x plus 6 is equal to 0. How do we solve this equation? There are multiple ways to do it, but one way is through factoring, right? This is x minus 2 times x minus 3 is equal to 0. And so here we have 2 quantities multiply to 0, or multiply and give us 0. That's only going to occur when one of the quantities is 0 itself, when x minus 2 is equal to 0, or when x minus 3 is equal to 0. So here we get x is equal to 2, and x is equal to 3. These are quantities we're tossing out from the domain. So the domain for this function, well, everything works, almost everything works except for these values that lead to division by 0. So everything outside of x is equal to 2 and x is equal to 3, right? So here, negative infinity all the way up to 2 is perfectly fine, but not including 2. We're tossing 2 out. Union, everything between 2 and 3, that's fine. And everything after 3, that's also fine, but not 3 itself, right? So here there's kind of a corresponding picture. So let me try and draw that again. Right, so here we're saying that really we're tossing out these values of 2 and 3 away from the domain, but everything else is okay. Right, and so really there's sort of 3 chunks of continuous numbers that belong in our domain. There's this chunk from negative infinity to 2. Maybe this makes it a little too cluttered. And there's another chunk from 2 to 3, but not including 2 and 3, and then there's a last chunk from 3 and onwards. And that's what we're describing in our interval notation. Okay, so the next example was g of x is equal to x squared minus 5x plus 6. So what's the domain of this function? And actually the domain of this function is from negative infinity to positive infinity. It's all real numbers. Right? No matter what I plug in, I can square it. I can take 5 away from that, 5 sets away of that input, 5 sets of that input away, and then I can add 6 on, and I can still get a reasonable output. Right? The reason that things went wrong here was that really there's a problem with division, so that dividing by 0 is a problem. Here, we don't have any notion of division being expressed in this function, and so I can plug in anything I want, and I'm not going to lead to division by 0. And so, for example, the x values of 2 and 3, although they lead to an output of 0, really they're perfectly fine for this function. They don't lead to division by 0, they don't lead to taking the square root of a negative number. Really, every real number belongs in the domain of this function. Okay, what about this example, p of x is equal to the square root of 3 minus x? Right, we're saying that this whatever 3 minus x, whatever number that comes out to be, because if we're taking the square root of that number, it should not be negative. Any time, any value of x that leads to a negative value for 3 minus x, that's not going to be included in the domain because we can't get a reasonable output. So this should not be negative for a corresponding x value to be in our domain. And so when is this not negative? Right, so our domain consists of all the values that make 3 minus x not negative. In other words, greater than or equal to 0. These are the values that'll make a reasonable output from this function. And so here we can solve this inequality by, I'm going to subtract 3 from both sides and get negative x is greater than or equal to negative 3. And then dividing both sides by negative 1 or multiplying both sides by negative 1 gives us x on the left, 3 on the right. And whenever we multiply or divide by a negative number to both sides of an inequality, we have to reverse that inequality sign. So any number that's equal to 3 or less than 3, if we plug such a number in, we'll get a reasonable output. It'll make the inside of that square root non-negative, and we'll get an output out. Right? Any other values will make that input or that inside of that square root negative, and we won't get a real number output. And so in interval notation, this is, what is this? This is x values less than or equal to 3. Right, so this is from negative infinity to positive 3, and we're including positive 3 itself. So these are numbers we can plug into our function. Okay, and then there's we had a similar problem, one last problem here, of q of x is equal to, this was x squared minus 3x plus 18 in the denominator, and the square root of 2x minus 8 in the numerator. So there's sort of two things going on here that we have to be aware of if we're trying to find the domain of this function. Right? So we know that for square root functions, really we should not be taking the square root of a negative number. We want to make sure that this 2x minus 8 is not negative for our input values. And then we want to make sure that our input values lead to not making this denominator 0. Right? Any such input that satisfies both of these conditions will lead to a reasonable output and should be included in the domain. And so here we get something in our domain if 2x minus 8, that's not negative. So here it's greater than or equal to 0 means not negative. And then we, solving this inequality, we get 2x is greater than or equal to 8, or x is greater than or equal to 4. Right, so that's this condition that we must not have this negative value underneath the square root for our domain. And then, we have another condition here that this denominator should not be equal to 0. And so when does that happen? Actually, maybe I'll do that in red, right? These are solutions to this equation, x squared minus 3x plus 18 is equal to 0. We should toss these solutions out because such values lead to division by 0 and won't be reasonable inputs to our function. And so how does this left side factor? It factors as x minus 6 times x plus 3 is equal to 0. And so, if x is equal to 6, right, x minus 6 is equal to 0 means x is equal to 6. That makes that equation 0, or that left side equal to 0. And then x plus 3 is equal to 0. also makes this equation true. So x is equal to -3. Okay, so these are meant to be not in the domain. They lead to division by 0 for our function. And so, you know, what's the picture here? Is that, you know, this our inequality in blue here, it's saying, you know, here's the number 4, and this is saying, okay, for our square root function or part of our function in the numerator, you know, everything's okay as long as we're bigger than or equal to 4. Our inputs are larger than 4 or equal to 4. Those are okay for the input, just for the square root part. But what we're also saying here is that there's this positive 6. This is not okay. We should sort of pluck out this input from the domain. It's just not okay for our denominator. Although it's okay for the numerator, it's not okay for the denominator, so it's not okay for the function as a whole. And then out here, there's another point, -3. So, you know, my number line isn't up to, it's not perfectly scaled, but hopefully it's kind of clear here. So -3, this is also leads to division by 0. It should not be included in the domain, but it wasn't going to be included in the domain because, you know, we already knew that the x values ought to be greater than or equal to 4. So we don't really have to even consider it, because as long as we sort of capture, you know, our solutions here, right? So this first solution set from 4 to 6, and as well as 6 or beyond 6, we've really got all the values that make sense for our domain, right? So -3 wasn't even going to be included, but, you know, sort of not included doubly so. So this is the domain of our function q of x.